let's start with evaluating and substituting in 0. The y-intercept, when you substitute in 0, the numerator just becomes -3, the denominator becomes 1, so we have 0, -3. We then look at the numerator. We factor it, and we find out that it factors into 2x plus 1 times x minus 3, and that tells us x equals -1/2, and 3 will be our x-intercepts. We then look at the denominator. When is the denominator equal to 0? Well, the answer is this is never 0, and that means there is no vertical asymptote. We then look at the degrees. We have x squared and x squared, so we're going to have the same degree, and that tells us to look at the ratio of the leading coefficients, and in this case we have 2/1, so y equals 2 is our horizontal asymptote. So let's go and plot all these things, beginning with the 0, -3 y-intercept. We'll then plot -1/2 as an x-intercept and 3 as an x-intercept. We will then plot our horizontal asymptote at y equals 2. And then we kind of stop for a minute because this looks quite a bit different than many of the other things that we have tried graphing before. So let's now do an xy chart. We already know that 0 gives us -3. I kind of want to see what's going to happen over here on the left a little bit. So I'm going to try -3, and when I substitute that in, it ends out that I get 3. -3 up to 3. Hey, we just crossed a horizontal asymptote. We are allowed to do that. We can cross horizontal ones, we just can't cross vertical ones. Let's substitute in 1, and it turns out that at 1 you get an output of -3. So 1, -3 right there. Woo boy. Okay, so let's see what we got. We know our graph is going to cross in the middle here somewhere. It's going to come down. It's probably going to dip a little lower. How far down, we don't know. It's going to come back up, and it's going to approach that horizontal asymptote. Now on the left, it can't just go flying up in the air. These horizontal asymptotes like to be obeyed. On the far left and the far right, you have to obey them and start to approach them. So we're going to start having our curve balanced down like that, and I'm just going to throw this in there for lack of any other points, and that will be the shape of our curve. Now, if we wanted to find the point of intersection here, we'd have to say, where is the y value equal to a height of 2? And that would mean solving the original equation here equal to 2. I'm going to do that very quickly. Here we go. Original function, 2x to the second minus 5x minus 3 over x squared plus 1. Where is that equal to 2? Let's now multiply through by x squared plus 1 to cancel out the fraction. We will have 2x squared minus 5x minus 3 is equal to 2 times x squared plus 1, which is 2x squared plus 2. And we can see that the 2x squareds are going to cancel out on each side. That gives us -5x minus 3 equals 2. -5x then is equal to 5, and therefore x is equal to -1. So when x is -1, y is equal to 2, and I should have plotted my point right there because it's going to go up there and then around instead. So that means let's scribble out this little portion right there. We're doing the best job we can.